10-5 and 10-6 today. With 10-5, it is about segments in circles, okay, their relationships. And then with 10-6, it'll be angles in circles and their relationships. So the first one we're going to talk about is tangents. Now, we've already talked about tangents. Remember, a tangent touches the circle how many times? One time. Now, that point that it touches the circle is called the point of tangency. Remember that. And what you have to know about the tangent line, it's only a tangent line if and only if it's perpendicular to the radius at the point of tangency. Perpendicular, remember, means that it's going to make a 90-degree angle. So if you see a radius and a tangent point, you're supposed to know that that's a 90-degree angle there. Okay? The other thing is something we already talked about also. If two segments, so two tangents, meet at the same external point, then remember that they are equal. Okay? Then you have to remember that they are equal. So those are two things that you're going to know about tangents here. So we're not going to go through the algebraic part of it. We're going to mostly set up, okay? So on number 1, how would I set up? X plus 3 equals 7, okay? Then I will solve from there. Number 2, how would I set that one up? X equals what? On number 2. You're supposed to know if it's a tangent line and it's a radius that this is supposed to be what? 90 degrees. So you would do Pythagorean theorem. You would do Pythagorean theorem to get that missing side. Okay. So you're supposed to know when you see a tangent line and a radius touching that that's going to be a 90-degree angle. Okay. All right, so you're going to be responsible for the rest of that page. Let's go to this side. Circumscribed polygons. Okay. Remember, circumscribed means it's on the outside of the circle, but it does mean that it's going to touch it at every point that it can. Okay. So realize that circumscribed polygons are a whole bunch of tangent lines. Okay. This is tangent, 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 tangent. It's a whole bunch of tangent lines put together. Can you sit up? So, you're supposed to know if they are tangent lines and they meet at the same external point that they will be equal. So you're supposed to know that this is equal to this. This one's equal to this one. This one's equal to this one. This one's equal to this one. Okay? So, looking at number 1. What would X equal? Huh? It would equal 23. Because this right here, this tangent line would equal how much? 10. So 10 plus 13 would give me the 23. Okay. All right, you're responsible for the rest of this page. All right, on this one, it's still talking about segment relationships in circles. So this one, what kind of segments are these? There are 2 chords, okay? This would also work for secants. So if it just was longer with arrows, you would still do the same exact thing, okay? So pretty much I recognize this one as when I see that X in the middle of my circle, I'm going to use this theorem. So the theorem is that you would take, on this example, HL times LJ equals KL times LM. So the way I think of it is part times the same part equals the other line, part times part. Okay? So I think of it part times part equals part times part. And the parts have to be the same chord. So this has to be the same chord. This has to be the same chord. Okay, so knowing that, how can I set up number 1? Seven times 3 equals what? 3 times y, or y times 3, and then I would solve from there. 7 times 3 is 21, equals 3y, so y equals 7. The directions say find the value of the variable and the length of each chord. So R S would equal how long? 10, and TV would equal 10. It's a coincidence that they're 10. Don't think that the chords will always be the same, okay? The chords are not always the same. Okay. All right, you're responsible for the rest of that page. Go to this side. All right, so now this one, what kind of segment is this? It's a secant, okay, because it goes through the circle, it doesn't stop, and so is this one. So it's 2 secants, okay? So this is 2 secants here. And then this one is a secant, and then this one's a tangent. The formula for 2 secants like this is whole times outside equals whole times outside. When it's a secant and a tangent, it's whole times outside equals tangent squared. So knowing that, how would I set up number 5?
8 times 4 equals
Whole times outside.
12 times
So 12 times 4.
equal to 6 times
Not 6, 6. Not 6. What's my whole? Not 6, 6. How did y'all get 12, people? How did y'all get 12? X plus 6, okay? X plus 6. And then my outside would be 6. So then when I do this, when I have 12 times 4, which is 48, equals what? 6x plus 36. You would need to distribute. Okay. So minus 36, that'll leave me with 12, equals 6x, so x equals 2. It says find the value of the variable and the length of each secant segment. So how long is in C? 12. And then how long is in S? 8. Okay. Any questions on that? All right, you're responsible for that also.